Welcome everyone to the fifth part of the series Analog Electronics. We have already studied semiconductors, PN junction, rectifiers, and transistors. The links to these video tutorials are provided in the description below. Now let's move to our next topic, that is transistor configuration, which is going to be the fifth part in our series. As we all know that every electronic circuit requires 4 terminals, 2 for input and 2 for output. The transistor has only 3 terminals, which does not fit the bill, and hence it was decided that one of the terminals would be made common so that the input can be provided between one terminal and the common terminal, and the output can be taken from the remaining terminal and the common terminal. As we can see that there are 3 different terminals in a transistor, each one can be made common, and depending on that we can have 3 different configurations or modes. The first is the common base mode, in which the base is made common and the input is provided in between emitter and base, and the output is taken in between collector and base. The next is the common emitter mode, in which the input is provided between base and emitter and the output is taken in between collector and emitter. The last is the common collector mode, in which the input is provided in between base and collector and the output is taken in between emitter and collector. Now this mode is not very popular and we are going to drop this from this tutorial. We are going to study only the common base mode and the common emitter mode. Let's move on to the common base mode. This is the circuit that we are going to use to study the characteristics of the common base mode. Let's see the elements of this circuit. The input is provided through a battery VEE. The output is provided through a battery VCC. The instantaneous input voltage is measured as VEB. The instantaneous output voltage is measured as VCB. The input current is the emitter current IE and the output current is the collector current IC. The direction of both the currents are shown in the figure. The base current IB is also shown. Now we can find 3 different characteristics from this circuit. First is the input characteristic, then the output characteristic, and lastly the transfer characteristic. In case of input characteristic, the output voltage will be kept constant and the parameters in the input side, that is IE and VEB, will be studied. In the second case, the output characteristics, the input current IE will be kept constant and the variation in collector current IC and the voltage VCB will be studied. And in case of transfer characteristics, VCB will be kept constant and the change in IC with respect to change in IE will be studied. Let's see what the characteristics for input look like. We have kept the output voltage VCB as constant and we have studied the variation of IE with respect to VEB. The curve, as you can see, is basically the curve of a forward bias diode. The curve also shows us that as we increase VCB, the cut-in voltage decreases. Now let's move on to the output characteristics. Here, as I told you before, the input current IE is kept constant and the changes in IC with respect to VCB are measured. As you can see, there are flat curves with respect to the VCB axis. This particular graph can be distributed into 3 different topics or 3 different regions basically. First is the cutoff region, where both the PN junctions, that is the emitter base junction and the collector base junction, are reverse biased and hence the transistor is cut off. The next is the saturation region, in which the emitter base junction and the collector base junction are forward biased and the transistor is on. In the previous case, the transistor was off. So a transistor can be made to switch between the saturation region and the cutoff region, that is on and off, and this gives the transistor one application, the application of it as a switch. We have already used this application in logic gates. The link to that tutorial is also given in the description below. Next is the most important part, the active region. The active region has all the flat curves. In this region, the output current IC is independent of the output voltage VCB. The magnitude of IC is solely dependent on the input current IE. So, the output current IC is determined by the change in input current IE. This finds an application of the transistor as an amplifier where the value of the output current depends or rather changes according to the value of the input current. So we have seen two uses of the transistors here. One is the switch, in which it can be made to switch between the saturation region and the cutoff region, and the second, the amplifier, where the transistor is operated in the active region. Mostly the transistor is utilized or operated in the active region only. Let's move to the transfer characteristics. In case of transfer characteristics, the output voltage VCB is kept constant and the change in output current IC is measured with respect to the input current IE. We can find a slope of this curve and it is given as alpha, or the current amplification factor, which is change in IC with respect to change in IE. Typical values of these common base mode alpha is 0.9 to 0.99. That is, the current amplification factor for common base configuration is 0.9 to 0.99. Sorry, 0.99. Let's move on to the next topic, that is the common emitter configuration. This is the circuit. Again, we will look into the elements. The input is biased by VBB, the output is biased by VCC, the input voltage is VBE, the output voltage is VCE, the input current is IB, the direction is shown by the arrows, the output current is the collector current IC, and this is the current IE. Let's move on to the input characteristics. For input characteristics, the VCE, that is the output voltage, is kept constant and the change in IB with respect to VB is measured. We can see that it is again like the characteristic that we have seen in case of common base mode. The only difference is that here the cut-in voltage increases with the increase in the output voltage VCE. Let's move on to the output characteristics. We will keep the input current IB constant and measure IC with respect to change in VCE. The curves are almost of similar character as in the previous case, but they have a slight slope. This can be also divided into the three particular regions, where both the PN junctions are cut off is the cutoff region or the off region. Where both the PN junctions are forward biased, it is the saturation region, and the active region. In the active region, the current IC is solely dependent on IB and it is not dependent on VCE. The slope of these curves are extremely small and don't create much effect on the changes. Now let's move on to the transfer characteristics. In case of transfer characteristic, VCE is kept constant and the output current IC is measured according to the change in the input current IB. The slope can be found again, and the slope in this case is called beta, or the current amplification factor in case of common emitter configuration, which is basically the change in IC with respect to IB. Typical values of beta are from 50 to 600. We can see that beta is higher in CE mode than, which is basically the common emitter mode, with respect to the CB mode, that is the common base mode, and wherever we require high amplification, we use common emitter configuration. Now let's find the relationship between alpha and beta. We know that IE equals to IB plus IC, which is the transistor current equation that we have seen in the previous tutorial. The current amplification factor for CB mode is alpha, that is IC by IE. Plugging the values we find IC by IB equals to alpha by 1 minus alpha, where IC by IB is nothing but beta. So beta equals to alpha by 1 minus alpha. We can also do little bit of mathematical jugglery and find alpha equals to beta by 1 plus beta. Transistors are a very important component. They can be used as switches, they can be used as amplifiers, and they are at the basic heart of all the integrated circuits. Some integrated circuits are operational amplifiers, very famous application of transistors, and that will be the next topic of our video tutorial. I hope you have liked this tutorial. Please do like, share and subscribe. Stay healthy, stay safe. Till then,